Out beyond the traffic of Earth's orbit, the solar system grows quiet. Sunlight softens to a pale wash, and the planets move like slow hands on an ancient clock. In that wide, dim space, Saturn hangs like a distant lantern, a soft glow wrapped in a thin veil of ice and dust. There, in the cradle of silence around its rings, one of our newest eyes on the universe is listening. The James Webb Space Telescope was built to see what other telescopes could not. Far from the noise of cities and storms, it drifts in a careful orbit around the point in space called L2, where gravity and motion balance just enough to keep it steady. It does not blink like a human eye. It simply turns its gold mirrors toward the darkness and waits for starlight to arrive. Most nights, the universe behaves the way textbooks say it should. Galaxies and nebulae shine with their ancient light. Webb turns toward distant exoplanets and measures small changes in their glow as they pass across their stars. Its spectrographs stretching the glow into thin bands that reveal clouds, gases, and hidden worlds. On one quiet night of observation, something different begins to appear in the flow of data. It does not arrive as a bright flash or as a streak like a comet cutting across the sky. It shows up as a small, steady wrinkle in the numbers. At first, it is only a tiny change, almost lost in the usual hum of cosmic whisper and solar wind. Yet it repeats. And then, it repeats again in a darkened control room back on Earth. Screens cast a soft glow over tired faces. The room is not loud. It sounds like most late-night offices do. A few distant keyboards, the faint buzz of electronics, the whir of cooling fans. Someone scrolls through lines of information, eyes tracing patterns that most people will never see. On one of those screens, the wrinkle grows a little clearer, like a faint footprint on untouched snow. If you are listening to this as you drift towards sleep, you are part of this story too. Across the world, people press play on videos like this. One New York at midnight, a small town in Texas, London before dawn, Sydney in bright afternoon. If you haven't already, subscribe and share where you are and what time it is as you listen. Those messages, scattered across the map, look a little like stars themselves. Small lights that tell us we are not alone on this planet, even as we listen for something beyond it. The anomaly near Saturn does not shout. It does not flare like a supernova or roar like a radio burst. Instead, it behaves almost politely, slipping in between the usual signals in a way that demands a second look. It is steady, structured. It seems to rise and fall in a rhythm that does not match the slow heartbeat of a pulsar or the crackle of charged particles dancing along a magnetic field. It is quiet in radio terms, more pattern than power, like a whispered code tapped gently on a wall. Saturn itself offers no easy explanation. The planet turns on its axis, its rings sweeping along their endless trajectory like a luminous halo. Frozen fragments of rock and ice spin in orbit, each a tiny traveler reflecting the sun's pale light. From Webb's vantage point, the planet is both near and impossibly far close enough to resolve as a glowing disk crossed with shadow, distant enough to feel timeless. There are known moons, known arcs of dust, known storms rolling under its cloud tops. Yet, in all those known motions, this unexplained signal feels like something that does not quite belong. As the hours pass, the telescope keeps collecting light. Data flows along invisible paths, from the spacecraft to relay stations, from deep space antennas to quiet server rooms. There, software begins to sort it, checking for glitches, clearing out noise, lining up each observation in careful order. The anomaly resists being cleared away. It stays, a thin vertical line in a sea of color, a repeating mark at the edge of what is expected. This part of Webb's story was supposed to be simple. The space around Saturn is a familiar neighborhood. Other telescopes have mapped it, Orbiters have flown past. Probes have skimmed the tops of its atmosphere and looped through its rings. Saturn has been a subject in textbooks and documentaries. For decades, a giant striped world with a crown of light, beautiful but understood. That is why the telescope's gaze passes over it, to check, to refine, to compare old knowledge with new precision. So when the anomaly first appears, it does not arrive like a prophecy. It arrives like an inconvenience. Perhaps it is a reflection from some human-made object. Perhaps a satellite has wandered through the field of view. Perhaps a charged particle from the sun has carved a line through the sensor at just the wrong moment. The first instinct is not awe, but caution. In science, most strange things have simple explanations hiding underneath, and yet, the more the team looks, the less simple it becomes. The signal is narrow, like a thin thread traced through the data. It is not smeared out the way a random hit should be. It does not drift in frequency the way many natural sources do as they move in their orbits. Instead, it holds its place with a stubborn grace, rising and falling with a rhythm that looks almost intentional, and then slipping back into silence. To describe the feeling in the room as this sinks in, you have to imagine a kind of double quiet. There is the literal quiet, the low murmur of machines, the soft click of a mouse. And then there is the quiet in people's minds as they realize they are looking at something that does not immediately fit into the usual boxes. Wonder does not arrive as fireworks. It shows up as a slight pause, widened eyes, a hand resting a little longer on a keyboard. Outside, Saturn continues its endless dance. Its shadow falls across its rings, turning them from bright silver to deep gray and back again. Tiny moons move along their invisible paths, shepherding arcs of ice and dust, carving gaps that circle the planet like grooves on a record. Now, though, there is this extra note, this faint, steady tick that was not part of the music before. The purpose of this first chapter is simple: to set the stage, to show that James Webb is not just a camera, but a careful listener, to show how a telescope built to study galaxies and exoplanets can also stumble upon an unexplained whisper closer to home, to let you feel the contrast between the fragile humanity of the people at the screens and the timeless calm of the planet they study. As you listen, you might picture yourself sitting in that control room, a mug of something warm in your hands, the soft glow of monitors painting quiet colors on the walls. You might imagine looking up at a plot of data where one line is just slightly different and feeling a tiny shiver of curiosity. Not fear, not yet. Just the sense that the universe has tapped gently on the window. For now, this anomaly is only a visitor, silent, small, and patient, hovering in the data near Saturn, like a drifting shadow no one expected to see. It will be checked, doubted, and tested, but the fact remains: it is there. And as the telescope continues its slow sweep across the sky, and Saturn glows on in its distant orbit, a question settles over the room like a soft haze. Is this little pattern in the noise just another trick of light, another echo of our own machines, or the first hint of something that has been waiting for a very long time to be heard? Saturn hangs in the dark like an ancient traveler, moving along its long orbit with a patience that makes human time feel small. From a distance, it looks almost simple, a soft glow in the endless night, but up close, its rings spread out like a gentle veil, thin and bright, made of ice and rock and forgotten comet dust. Around it, moons glide in patient loops, each following its own quiet trajectory, each casting a drifting shadow across the planet's pale face. If you could float out there, far beyond Earth, Saturn would not be silent at all. You would hear the whisper of the solar wind brushing against its magnetic field, the soft hiss of charged particles trapped in invisible lines. You would see the rings catching starlight, each tiny piece of ice turning the sun's rays into a shimmer, like a million small mirrors. Even the smallest asteroid fragment, once a wanderer of its own, now joins the cosmic dance around this giant world dot from Earth, though most of us only see a pale dot. A child in a backyard might point a small telescope toward the sky, guided by an app or a star chart, and slowly bring Saturn into view. The image is small, a tiny ball with two clear, thin lines wrapped around it. Yet in that moment, all rises. You are looking not at a picture in a book, but at a real world, its rings, its moons, its storms, all there, hanging in the darkness. The planet becomes more than a fact. It becomes a memory. That small backyard telescope is only one of many. Watching eyes. All across the world, other telescopes stand like quiet sentries on mountaintops and deserts, their domes opening at dusk. Mirrors tilt and turn. Motors hum softly as they follow the motion of the sky, keeping stars centered as Earth spins. These instruments do not just look. They measure. They record how starlight changes, how a comet shifts its path, how a faint meteor streaks and vanishes far beyond them all. The James Webb Space Telescope orbits near a point called L2 on the far side of Earth from the Sun, where gravity and motion balance in a delicate cradle of silence. Up there, Webb is not troubled by clouds or city lights. Its mirrors unfold like a golden flower, catching ancient light from galaxy clusters, nebulae, and exoplanets that orbit distant suns. It reads that light with precision, using a spectrograph to spread it into colors, the way a prism turns sunlight into a rainbow. Spectra look like simple lines and stripes on a screen, but each line is a story. One line can whisper hydrogen, another oxygen, another methane. From those patterns, scientists learn about atmospheres, temperatures, and motions. They can tell if a comet's tail is rich in ice, if a distant exoplanet has clouds, if a nebula is birthing new stars. The universe becomes not just a picture, but a language written in starlight. When telescopes turn towards Saturn, they are not just admiring its beauty, they are reading its environment. They watch how its rings scatter light, how small moons weave through gaps like shepherds, guiding ring particles along stable paths. They follow the trajectory of passing objects, asteroids, comets, and stray meteor fragments as they come near and move away again. Every orbit, every line traced across the sky, is another detail added to our understanding of this ancient traveler and its surroundings. Dot in the background of these observations, there is always a gentle noise. Space is full of signals. The pulsing radio beat of a distant pulsar, the steady glow of a nebula, the faint crackle of cosmic microwave background radiation that has traveled since the dawn of time. Most of it blends together into something like a cosmic whisper, a constant hush of information washing over our detectors. Scientists learn to see through this, to find patterns that matter and ignore the rest. Imagine yourself now, lying in bed, eyes half closed, listening to this story. You picture Saturn wrapped in its rings, a pale giant wrapped in a luminous haze. Around it, moons glide in slow motion. Behind it, the Milky Way stretches like a soft brushstroke across the sky, full of stars and shadows. Somewhere in that scene, telescopes both on Earth and far above it are watching, patient and unblinking. Their sensors count photons one by one, turning faint glimmers into data. A backyard observer, a mid-sized observatory, and a giant telescope like Webb are all part of the same network of listening eyes. One sees Saturn as a tiny circle and rings. Another sees it as lines of color across a spectrograph. Webb sees background galaxies and distant exoplanets shining behind it, their light bending slightly as it passes near the planet's gravity. Layer these views together, and you get not just an image, but a feeling. Saturn as a crossroads, a place where light, dust, and time meet in long exposures. Saturn becomes part of a wider canvas, Behind its rings, faint nebulae glow like smudges of color. Farther out, galaxy clusters sit like islands in a dark sea, each home to billions of stars. A single frame of data can hold an entire history book of the cosmos. A comet caught midway through its orbit, a meteor trail fading near the edge, a distant exoplanet dimming its star by a fraction of a percent as it passes in front. Every pixel of that image, every tick of data in a graph, is checked and cataloged. Computers automatically scan for movement, comparing one night sky to another. If a tiny point of light shifts position, the system marks it as a candidate, maybe an asteroid, maybe a comet, maybe a satellite passing through. Most of these are known, logged in catalogs that have grown for decades. Their paths are predictable. Their behavior matches the rules. But hidden within the glow and the motion, there is always room for something unexplained. A small anomaly, a pattern that doesn't quite fit the usual models. It could be a glitch, a reflection, a stray satellite echo bouncing in a strange way. Or it could be something else, a messenger we do not yet recognize. A quiet signal threaded through the noise dot as you drift closer to sleep. Imagine the entire solar system as a dimly lit room, and Saturn as a lamp in the corner, ringed and remote. Around it, dust and ice circle in a slow, endless dance. The telescopes that watch it are like eyes at different windows, peering out through the darkness. Their spectrographs and sensors keep listening, always listening, for anything out of place. Somewhere in all that data, at some quiet moment, a tiny deviation first appears. A faint, structured curve. A rhythm that does not match the usual sway of orbits or the static hiss of background radiation. It is small enough to ignore, easy to dismiss, and yet it sits there, waiting for the right pair of human eyes to notice dot. And when those eyes finally pause on that subtle shape, when a person leans closer to the screen, feeling a flicker of curiosity, it is as if the universe itself has cleared its throat. The question rises softly. Who was the first to truly see this anomaly near Saturn's glow? And in that fragile, timeless instant, did they understand what they were looking at, or did it simply feel like a strange new whisper in the dark? It begins on a quiet night when almost nothing is supposed to happen. Far from Earth, the James Webb Space Telescope moves in its steady orbit around the Sun, parked in deep space beyond the Moon. Its mirrors sit folded inside a cold metal frame, wrapped in shielding that keeps out heat and stray light. It does not feel the night, or the cold, or the distance. It simply watches and listens down on Earth. In a small control lab, the scene is much simpler. No alarms, no blinking red lights. Just a few computer monitors casting a soft glow across the room. The gentle hum of cooling fans, and one person at a desk, watching numbers crawl down the screen like slow rain. The analyst has seen this view many times. Their job is not glamorous. It is patient. They make sure the river of data arriving from Webb keeps flowing. Clean, steady, and complete. Infrared measurements, spectrograph readings, calibration checks, line after line of information that, to most people, would look like meaningless digits. To them, it is the telescope breathing. Tonight, part of Webb's attention is sliding past Saturn's neighborhood. The telescope is not staring directly at the planet, but its field of view brushes by the region of the rings, sampling the quiet around that ancient traveler. Out there, tiny icy bodies move on slow, graceful trajectories like drifting shadows, following unseen paths. On the screen, everything looks normal at first. Columns of numbers, small plots in the corner, telemetry values that say the spacecraft is healthy and calm. The loudest sound in the room is still the soft, steady tapping of keys. Then, almost shyly, the pattern begins to shift dot at first. It could be anything. A tiny rise here, a small dip there. the kind of thing an experienced eye learns to ignore. Instruments warm and cool. Cosmic background noise ripples. The universe is not a perfect, smooth line. On another night, with more fatigue or more distraction, the analyst might scroll past without a second thought. But tonight, something about the change feels too tidy. They lean in, letting the monitor's pale light wash over their face. With a few keystrokes, they call up the raw web data for this small window of time, tracing its path backward. From the telescope's sensors, the signal was compressed, sent across space as a tight beam, caught by a ground station dish, unpacked, checked, and finally delivered here, to this quiet room dot. Now they open the spectrograph view. Normally, this tool shows smooth bands where starlight has been stretched into colors the human eye cannot see. Those bands reveal temperature, motion, and chemistry, a soft code written by distant gas and dust. But in the region tagged near Saturn's position, something thin and sharp lies across that smoothness. Like a barely visible scratch on glass, a small spike rises above the background. Then there is a pause. Then another spike. The same pause. Again and again. A tiny rise. A gap. A tiny rise. A gap dot. It is almost disappointingly simple. It is not a roaring flare from a supernova. It is not the rapid drum-like beat of a pulsar. It is a faint, repeating lift in the line. Soft, regular, persistent, like a quiet knuckle on a distant door. The analyst's eyebrows draw together. They have seen many strange shapes in data before. Satellites flashing sunlight as they tumble. Comets leaving thin signatures of dust and gas. Small asteroids briefly cutting across a telescope's view. They have also seen all the ways software can pretend to be the sky when it is really just broken code dot in their mind. The familiar doubts begin to line up. It's noise. It's a glitch. It's one more artifact to tag and forget. But the pattern keeps repeating. They ask the computer to check known objects. A search runs through catalogs of comets and asteroids, through lists of spacecraft whose orbits bring them near this part of the sky. Nothing quite matches. The timing of the spikes does not fit the spin of any cataloged satellite. It is not lined up with expected meteor activity in Earth's atmosphere. It does not resemble a brief reflection of space junk. The analyst stretches the time axis, zooming out to watch a longer slice of the night. The spikes march on in their calm rhythm. Then they zoom in, slicing the data into smaller and smaller pieces. Even at that scale, the spacing holds steady, like a metronome hidden in the noise. Too regular to be random, too odd to be comfortably familiar. They run the data through a filter that strips away common interference. Background hiss falls away. Thermal noise softens. What remains is thinner now, but its shape is still there. A faint, stubborn pattern from the direction of Saturn dot with another few clicks. They call up the log of automated algorithms that quietly watch Webb stream. These systems look for anything that strays from ordinary behavior, sudden jumps, odd dips, unusual curves that might signal either a problem with the telescope or something interesting in the sky. One entry near the current time is highlighted. Unexplained. Deviation, the note reads. The word unexplained has weight here. It does not mean mysterious visitor. It means no clear match yet. Still, seeing it attached to this quiet rhythm makes the analyst sit a little straighter. They rewind the night. Data from earlier hours scrolls across the screen. Before this segment, everything looks like normal cosmic background. The telescope tracks as expected. Its orbit is steady. Guiding systems hold it on target with calm precision. Saturn keeps its place, continuing its long, predictable path through the dark. Then comes this narrow slice of time, and the line on the graph begins to tap dot to check for trouble. They call up other instruments. If the spacecraft is misbehaving, Signs usually appear in more than one place. But the thermal readings look normal. Power levels are steady. Pointing control hasn't twitched. The telescope's heartbeat is smooth and unbothered. Only the spectrograph shows this quiet, stubborn rhythm. They sit back and let their eyes rest for a few seconds, staring past the screen into the dim room. Out there, far beyond any window, Webb floats in deep space like a fragile metal flower. It does not know it has seen anything unusual. It only turns light into numbers and sends them toward home. Here, the numbers turn into meaning or into questions. Leaning in again, the analyst begins to test simple models. On the screen, they simulate a comet crossing behind Saturn. Imagine a clump of ice and rock throwing off gas in a way that might cause repeating changes in the light. But the timing is wrong. The pattern is too clean. They try a rotating object. Small moon or chunk of debris spinning in such a way that its reflective surfaces would glint at regular intervals. They run the math on possible orbits and spins. The curves on the plot refuse to line up. Each natural idea slides past the data and falls away with every failed explanation. The spikes on the graph seem a little more alone. Still, the analyst is careful. They know the long history of astronomy is full of false alarms and misunderstood signals. They think of the early days of pulsar research, when the first regular beats in radio telescopes were half-jokingly labeled as messages from little green men, only to turn out to be neutron stars. Extraordinary but natural. This, they remind themselves, could be another such trick, an unknown calibration issue, a sole software bug, a tiny effect nobody has modeled yet. Even so, the feeling remains. This does not fit any familiar box. They begin to document everything they have done. Each test, each filter, each comparison. Timestamps, settings, notes, if anyone else looks. At this later, they must be able to follow the path step by step. They save plots of the repeating spikes, overlay them on the usual smooth background, and send one to print. A moment later, a warm sheet of paper slides onto the tray. On it, the pattern looks even starker. A thin line rising and falling with quiet discipline, marching across the page. Just ink and white space. Yet, in this room, it has the strange presence of a message found on a shore. The analyst holds the paper for a moment, feeling the faint grain under their fingertips. Then they look back at the screens and realize they have reached a small, private fork in the road. One option is simple. They can mark the anomaly as a likely artifact, file it for later review, and let it sink into the archive. If it matters, someone might stumble on it down the line. If it does not, it will become one more odd wrinkle in a sea of data. The other option is slower. They can treat it as something that deserves attention. They sit there, listening to the low hum of the fans and the gentle ticking of the clock on the wall, watching the line of spikes wait patiently on the screen. A soft unease stirs at the edge of their thoughts, not fear, just the feeling that something hidden is raising its hand. Their fingers hover over the keyboard. With a quiet breath, they open a new report. They attach the plots, the logs, the failed models. They label the pattern as an unexplained anomaly in data taken near Saturn's position and flag it for deeper review. Finally, they send a request for another analyst to look, not later, but soon. That single choice to double-check instead of dismiss changes the night in a way no one outside this room can feel. Outside, Saturn keeps circling in its timeless orbit, rings catching distant starlight. Webb continues to collect light, calm and tireless, as if nothing unusual has occurred. But in this small lab on Earth, an unnoticed rhythm has stepped out of the background, and a human mind has decided it is worth listening to. The monitors continue to glow. The fans continue to hum. And somewhere beneath the numbers and the noise, a new question has quietly come to life. settling into the darkness like a fragile spark that refuses to go out. The night around Saturn is calm, a wide cradle of silence wrapped in a soft glow of distant starlight. Far away, in a quiet control room on Earth, that calm is broken by something very small. A thin, stubborn line in the data from the James Webb Space Telescope. It is not bright. It is not dramatic. It is simply different. Before anyone lets their mind drift toward words like alien or message, there is a rule everyone in the room understands. First, you clear the board of every ordinary explanation. You start with the usual suspects. Engineers and scientists sit at rows of gently humming computers. The only sounds the low buzz of cooling fans and the soft tapping of keys. Pale light from monitors paints their faces as graphs, timestamps, and orbit maps slide past like slow waves. On one screen, the signal's odd pattern sits like a knot in a smooth thread. On others, long lists of human-made objects crawl by satellites, probes, stations, everything we have ever flung into. Orbit or out toward the planets. The first suspect is always us. Telescopes do not listen to a quiet sky. They listen through a crowded shell of our own technology. Communication satellites, beam calls, and videos across continents. Weather satellites watch cloud bands swirl. Navigation systems send constant pulses, like heartbeats, around the Earth. Their signals bounce and reflect, sometimes slipping into places they were never meant to go. The team pulls up catalogs of these machines, each with its own orbit and trajectory, carefully logged on a large display. Curved lines sweep across a digital sky, each arc marking where a satellite was at a given time. The engineers line the picture up with the moment Webb caught its anomaly. Did anything pass through its field of view right then? They check altitude, angle, and frequency. Too low, too high, too far to one side. Wrong kind of transmission. One by one, satellites are crossed off, their names dimming from bright white to gray. The signal does not follow them out the door. It stays dot next. The team turns inward. If it is not something outside the telescope, perhaps it is something inside. Instruments grow tired. Sensors warm and cool. Tiny imperfections in hardware can create patterns that look, for a while, like something real. In the past, strange spikes in data were traced back to loose cables, aging detectors, or a few misplaced lines of code. The people in the room know those stories well. They run calibration routines, feeding known test signals through Webb's processing chain to see if anything bends or breaks. They study dark frames, images taken with no starlight at all, used to catch hidden noise in the electronics. They compare the data from that Saturn observation with data from nights before and after. If the same pattern appears everywhere, it smells like an instrument problem. If it appears only when Webb stares towards Saturn, that points in a different direction. Hours pass like slow-moving clouds. The results return, steady and uneventful. The detectors show no new scars. The software behaves the same way it did when measuring distant nebulae and exoplanet atmospheres. Internal logs are quiet, no warnings, no errors, no sudden jumps. The signal shape survives this inspection unchanged. The telescope, for all its complexity, seems innocent. Beyond Earth, the sun breathes a constant, gentle stream of particles into space. Sometimes it flares, hurling great waves of energy outward. These storms can rattle spacecraft, blind sensors, and create bursts of noise in radio receivers. So the team asks another question. Was the star at the center of our solar system misbehaving? That night, they pull up space weather reports. Satellites that watch the sun show smooth, low curves of activity. No sharp spike, no sudden flash. Solar wind speed was normal, its whisper brushing past planets in its usual way. There is no sign of a coronal mass ejection or flare to blame. The sun, on that night, was calm. It joins the list of suspects gently crossed out. Then come the wanderers. Asteroids, comets, and tiny pieces of rock and ice that crisscross the solar system like ancient travelers. A small body drifting through a telescope's view at just the right angle can reflect sunlight or disturb a signal for a moment, leaving behind a puzzling blip. The team turns to sky surveys and databases of known objects, from near-Earth asteroids to bodies that roam near Saturn's orbit. On screen, another map appears, filled with thin lines tracing the paths of these objects. Their orbits curl and intersect like threads in a tapestry. Could a faint comet at perihelion have swung through Webb's line of sight? Could a dim asteroid, too small for regular tracking, have flashed briefly in front of a background star? Model after model is run, each one checking position and timing against the moment the signal appeared. The answer, once again, is quiet. Known rocks and ice do not match. No meteor storm brushed past. No cataloged comet crossed that precise patch of sky. The anomaly is not a reflection from a dusty tail, not a meteor slicing through Earth's thin upper air, not a stray shard glinting in the dark dot to make sure. The team listens outward. They send quiet messages to other observatories, ground-based telescopes, radio arrays, even smaller instruments pointed by chance toward roughly the same region. Did you see anything? Did your detectors twitch? Most responses are simple. No. Anomaly, only the usual background of stars and galaxies. A few share smooth spectra and calm images, just steady starlight and the faint glow of distant nebulae. Against this ordinary backdrop, Webb's odd little pattern stands out even more. The work is repetitive, but in a soothing way. Logs are scanned, plots are overlaid, times are converted from one clock standard to another. Each small task peels away another layer of doubt. For you, listening in the dark, it might feel like watching someone slowly sift sand through their fingers, letting the grains fall away until only a single pebble is left in their palm. With each explanation removed, the room grows quieter. People speak less, and when they do, their voices are soft. The signal has survived contact with human error, with the busy shell of satellites around our world, with the breath of the sun, and with the wandering stones of the solar system. It remains as fragile and persistent as a single note held in the air after the music stops. You might picture yourself in that control room, eyes resting on the simple curve of the anomaly. A rise, a fall, a pause, and then the same shape again. No sharp spikes, no violent bursts, just patient repetition. The universe often shouts with supernova and black holes, with violent collisions and blazing jets. This is something else. It feels less like an explosion and more like a soft knock on a distant door dot. By the time the last obvious suspect is crossed out, there is no celebration. No one raises their voice. There is only a deeper sense of attention, as if everyone has leaned in at the same time. The data on the screen has not changed at all, but its meaning shifted. What was once just an odd bump is now an unexplained signal that has passed every simple test. If it is not clearly human and not any familiar force of nature, then it belongs to a smaller, stranger category. Perhaps it is a new kind of natural phenomenon, a behavior the cosmos has always had, only now bright enough for us to see. Perhaps it is something else, entirely a messenger of a kind we do not yet have words for. For now, it remains a question, made of numbers and light dot, and in that dim room, lit by the glow of telescopes' distant eyes, the question hangs there with the same quiet weight as the signal itself. When every usual suspect is gone, what kind of secret is the sky still keeping? On quiet nights, long before Webb turns its golden mirrors toward Saturn, the story of strange signals is already being written in the dark. For decades, People have aimed dishes, antennas, and telescopes into the sky, hoping that somewhere inside the soft glow of starlight, a pattern might appear. Not a shout, not a roar, just a thin line, a brief spike, a cosmic whisper that refuses to blend into the noise. To understand today's silent signal near Saturn, the narrator steps back through time. The room fades, and we are carried to another control center, another night. Paper printouts curl on a desk. A pencil rests between tired hands. The buzz of old machines fills the air. Somewhere, a red pen circle marks one strange moment in a river of numbers. 3 simple letters will turn that circle into a legend. WOW, the WOW. Signal arrives in 1977, but it feels like something older, like a ghost story passed from watcher to watcher. A radio telescope in Ohio listens to a narrow slice of the sky, scanning line by line. Most of the time, it hears only the usual murmur of the universe, the hiss of our own galaxy, the hum of distant objects, the fading afterglow of the Big Bang. But for 72 seconds, something different breaks through. A sharp spike appears in the data, like a single bright note in a quiet song, then disappears. The person checking the printout cannot help themselves. They circle the spike and write one word in the margin. Wow! That small reaction will carry the signal's name for decades. For many, it becomes a symbol of everything unknown and unexplained in our search for other minds. It is a reminder that the universe sometimes sends something that does not fit our labels, then slips back into silence. The narrator describes it not as a scream from the stars, but as a brief brush stroke across the sky. It does not repeat. It does not come back the next night. No comet is known in that direction. No nearby satellite matches its timing. As the years pass, scientists test one idea after another. A hidden transmitter on Earth, a reflection from a passing object, a natural source we still do not fully understand. Yet the mystery remains. The WOW signal sits in our memory like an unanswered question, glowing quietly in the dark. From there, the story drifts forward, closer to our time. Technology improves. Computers grow faster. Telescopes spread into networks, connecting across continents. Instead of paper printouts, researchers stare at glowing screens, watching streams of data pass like a digital river. And inside that flow, new anomalies begin to appear. Fast radio bursts are some of the strangest. They flash across the sky in less than a blink. One moment, the telescope hears only the usual background. The next, a bright pulse crashes through, then vanishes. A few appear once and never again. Others repeat like distant beacons turning slowly in the dark, as if something far away is tapping once on the glass of the universe. Explained simply, a fast radio burst is like someone snapping their fingers in a huge silent room. The sound is tiny, but it stands out because the room is so quiet. In space, that room is the cradle of silence between galaxies. No one knows for sure what causes all these bursts. Some may be linked to collapsed stars or objects near black holes. Others may come from events we have not yet named. A handful remain stubbornly unexplained, like hidden messengers that appear and disappear before we can read their full meaning. The narrator lets the listener imagine the people behind these discoveries. Astronomers sit under dark domes or in windowless rooms, their faces lit by screens. Coffee cools beside notebooks. They lean in closer when a new anomaly appears, the way someone might lean toward a campfire when a storyteller lowers their voice. Hope flickers. Could this be it? Could this be the pattern everyone has waited for? Yet with hope comes disappointment. Many signals that once looked special turn out to be tricks. Researchers trace some strange bursts not to deep space, but to simple devices on Earth. A microwave door opened too soon. A satellite glint. A reflection from an airplane. Interference from cell towers. For a while, They dress themselves up as cosmic whispers. Then calibration improves, filters sharpen, and the illusion breaks. The harbinger becomes a glitch. The messenger becomes a machine. These mistakes are not failures. They are steps on a long path. Each false signal teaches how fragile our methods are. It reminds us that we listen from the bottom of a noisy atmosphere, surrounded by our own technology. We are trying to pick out a single gentle voice from a crowd that never stops talking. The story then moves to pulsars, spinning neutron stars that beam radio waves into space like cosmic lighthouses. When they are first discovered, their repeating pulses are so regular that some scientists wonder if they could be artificial, a sign of a distant civilization. The first one is nicknamed LGM-1, short for Little Green Men. It is a quiet joke, but it shows how ready the human mind is to imagine another presence behind an unexplained pattern. Now we know pulsars are natural, born from collapsed stars with powerful magnetic fields. Their beams sweep across space in rhythm as they spin, marking time like a cosmic clock. But those early days live on in the story of our search. For a short time, a pulsar is an unanswered question, a possible messenger. When the natural explanation arrives, the sense of wonder does not vanish. It simply shifts into a new place, into the physics of extreme matter, into the strange beauty of a star crushed into a city-sized orb dot. As the narrator moves through these examples, the thread tying them together is clear. Again and again, people encounter something that does not fit, an unexplained spike, a drifting shadow in the data, a pattern that looks too sharp, too organized, too different from the usual noise. For a moment, they stand at the edge of discovery. On one side is a real finding. On the other is a mirage dot. The line between those two sides is thin and fragile. It is shaped by our tools, our training, and our patience. With a less sensitive telescope, a fast radio burst might never be seen. With poorer filters, a satellite glitch might look like a beacon. With slower computers, a repeating signal might be missed entirely. The universe has always been sending its signals. Our ability to notice them depends on how carefully we listen. The chapter lingers on this idea. Imagine a galaxy cluster shimmering at the edge of what our telescopes can see, an ancient traveler made of hundreds of billions of stars. Deep inside it, some event sends out a burst of energy in a tight beam. That beam crosses the emptiness for millions of years, a lonely messenger moving through endless night. If it passes through our part of the sky before we have the right instruments, it will glide by without leaving a mark. The story happens, but for us it is as if it never occurred. In the same way, the wow signal and other anomalies may be memories of a time when our ears are just beginning to open. We catch a hint, a whisper, but not enough to understand the language. Our spectrographs are simpler, our archives smaller, our systems less coordinated. What might we have missed? What patterns could have been hiding in those early data sets, waiting for a level of analysis that did not yet exist? The narrator invites the listener to rest with that thought, not as regret, but as a gentle reminder of how young our search really is. Compared to the age of the universe, our time with radio telescopes and space observatories is a single heartbeat. We are still learning how to tell a real anomaly from a passing glitch, a true cosmic whisper from our own echo. Coffee cups empty, computer screens dim, and old observatories fall quiet. Yet the records remain. Boxes of printouts, hard drives full of archived signals, pages of handwritten notes where someone once underlined a strange number. In those archives may sit forgotten hints, waiting for new eyes and smarter tools. They are like faint footprints in dust, hard to see until the light hits at just the right angle dot as the chapter closes. The focus drifts back to the present mystery, the silent signal near Saturn. The listener is left with a soft question hanging. In the air were those earlier messengers like the wow, spike, the first bursts, the misread pulsars arriving before we had the skill or the patience to truly hear them. Or were they gentle practice notes, teaching us how to listen so that when the right pattern finally appears, we will recognize it? In the deepening quiet, it feels as if the universe has been speaking all along, and we are only now learning to understand the pauses between its words. The screens are dimmed to a gentle glow, the way nightlights are turned down in a room where someone is trying to sleep. On one of them, a river of numbers slides past in slow, steady lines. Most of it is ordinary noise. The soft hiss of the universe, the background breath of starlight and cold dust. But hidden inside that endless stream, something begins to tap that it does not roar. It does not flash. It simply repeats. The analysts first notice it as a small, stubborn bump in the data. A rise, a pause, a rise again. Spaced so evenly it feels less like chaos and more like rhythm. If you could hear it as sound, it might be a quiet knocking against a faraway door, patient and calm. On the graphs, it looks like a tiny fence of bumps standing in the middle of a flat field. They call it an anomaly at first, because that is the safest word. An unexplained pattern. A cosmic whisper dot to understand why it stands out. You have to understand the noise that surrounds it. The James Webb Space Telescope does not float in silence. It sits in a cradle of gravity and sunlight, feeling the push of solar wind and the pull of Earth and Sun together. Every second, its instruments drink in light from stars, nebulae, comets, asteroids, and distant galaxies. Spectrographs split that light into rainbows of information. Thin brush strokes across the digital sky. Most of that information is messy. Particles collide. Photons arrive late. A meteor streaks through a field, its trail turning up as a brief, sharp spike. A satellite glides past, a bright intruder in the dark. All of it mixes into a shifting background. The analysts call it the noise floor. You might think of it as the constant murmur in a crowded room. A signal, if it is real, has to rise above that murmur. In simple terms, they look for order. They look for repetition. They look for anything that refuses to blend in. One of the scientists explains it like this. Imagine standing on a beach at night. The waves crash and hiss and fade. That's the noise. Then, somewhere in the distance, someone starts hitting a drum. Softly, steadily. If the rhythm keeps going, your brain locks onto it. You can't ignore it anymore. The pattern near Saturn feels like that soft drum. The team begins to measure it. First, they mark the peaks. 1, 2, 3, 4, like counting heartbeats. The distances between them are almost perfectly even. They run a simple binary check, treating each moment as a 1 or a 0, pulse or no pulse. When they translate a small section into a string, it no longer looks like random splatter. It looks like a line of beads laid out with care. They do not claim it is a code. Not yet. They remind themselves that nature can be neat. Pulsars spin with clock-like precision. Orbits follow smooth curves. A comet at perihelion returns to the same path again and again. But those natural patterns usually shout in clear ways. Loud radio bursts, strong X-ray flashes, or bright changes in starlight. This is different, This is quiet. The mystery lies in what is missing. The signal carries structure without the usual roaring carrier, like someone tapping a message on a wall without speaking a word. It does not show the broad, powerful shoulders of a normal transmission. Instead, it rides just above the noise. Floor, fragile and thin, as if it is trying not to be seen. To separate it from the background, the analysts improve the signal-to-noise ratio. They stack data from multiple passes. They smooth out random spikes, subtract known sources, and let the computers average away anything that does not repeat. Slowly, the scattered static melts away, like fog lifting from a coastline. The pattern remains, a lighthouse beam sweeping through fog. That is how one of them describes it. Every few moments, the beam swings by, and the detectors brighten. Then it passes, and the numbers sink back into their gentle rest. If you plot these moments over time, they draw a clean rhythm across the screen. No drift, no wobble, no simple mechanical fault. Someone suggests viewing it as music. They map the peaks to soft notes on a scale and press play. Out of the speakers comes a slow, patient tone, rising, pausing, rising again. It is not a melody, not in any human sense, but it is also not chaos. It is a brush of sound against the edge of hearing, like a single bell rung over and over and a sleeping city dot in the room. The sense of wonder grows. The team checks the direction. The telescope was aimed near Saturn's path when the pattern appeared, studying cold dust and faint starlight at the edge of the planet's reach. The trajectory lines up with the region where the rings stretch like a frozen halo, a gentle veil of rock and ice circling an ancient traveler. They cannot say the signal comes from the rings, but they cannot rule it out either. They test for motion. If the source were on Earth, fixed to some piece of ground equipment, the angle would not shift with the telescope's orbit. If it were a satellite, its track would cut across the field in a clear path. Instead, the pattern seems to hang in the same patch of sky, drifting only as much as Saturn itself drifts along its orbit around the Sun. It is as if an unseen object is hovering there, riding in the wake of the planet like a small boat behind a great ship. Still, they are careful. They compare with data from other nights, other instruments, even other telescopes. Again and again, in that same corner of the sky, just on the edge of Saturn's domain, the gentle knocking appears. It is not strong enough to dominate the view. It is not dramatic enough to announce itself. But it is there, a patient messenger. At the threshold, late, when the room is quiet and the screens glow like tiny moons, it is easy to imagine the signal as a heartbeat. Not of a creature, exactly, but of some process or structure, repeating its cycle in the darkness. A natural engine in the cold, or a careful device left to watch and listen. No one says this in the reports, but the thought lingers at the edge of their mind's as you picture it. You might imagine yourself above the rings, wrapped in a cradle of silence. Below you, shards of ice and rock drift like slow snow, catching faint starlight. Somewhere in that luminous haze, a small, steady pulse moves through the dark, like a distant beacon under a deep ocean. You cannot hear it, but you can feel the idea of it, ticking away in the background. Is it a natural cosmic heartbeat? The kind the universe has been beating for ages without our notice? Or is it something that wants to be read a quiet code? From an unknown traveler hiding in the shadow of Saturn, waiting for a curious mind to listen long enough and look closely enough to understand. For now, the only answer is the pattern itself, repeating softly in the quiet, a question written in the language of time. There is a moment in the story when the hard lines of data begin to blur, just a little into the shape of a question. Around Saturn, under that soft glow of rings and drifting moons, speculation begins to rise like mist over a still lake. The signal is there in the record, steady, patient, an unexplained pattern lying close to the ring giant's orbit. And as the numbers settle, a quiet idea surfaces in more than one mind. If someone wanted to watch our solar system without being seen, this is exactly where they might choose to hide. Scientists do not jump straight to aliens. They start with geometry. In calm conference rooms, they draw Saturn's orbit as a pale circle, then sketch the wide band of its rings like a delicate bracelet around an ancient traveler. They mark the positions of moons Titan, Enceladus, and the smaller, icy fragments that glide like tiny sentinels. Then they overlay the path of the anomaly, the trajectory of the signal's apparent source. Does it cross the ring plane? Does it move with a moon, like a drifting shadow that refuses to leave its side? On screens, glowing dots and curves shift. As models are adjusted, each one a new guess at where a hidden object could be done to understand the fortress idea. They return to what Saturn really is. The rings are not solid, but oceans of ice and rock, pieces ranging from dust grains to mountain-sized chunks, all locked into orbit by gravity and time. Sunlight catches these particles and turns them into a gentle veil of starlight, a luminous haze that reflects and scatters. From far away, the rings look like a simple brush stroke across the sky. Up close, they are chaos, a storm of frozen debris, circling in a cradle of silence. Any small craft slipping through that storm could vanish into the noise, its presence hidden by the constant shimmer of moving material. A telescope on Earth, or even James Webb far from our planet, sees Saturn's region as a mix of signals. The planet's reflected sunlight, faint emissions from the rings, tiny flashes from dust smacking into particles, and the distant glow of a nebula or galaxy cluster behind it all. In that crowded field, a small signal can be hard to separate from the cosmic whisper of background radiation. The Saturn Fortress hypothesis imagines an advanced probe using that confusion as cover, aligning itself with the ring plane so that any emission it sends is easily lost inside the glow of ordinary physics. It would be like whispering from behind a waterfall, the sound there, but hard to pick apart from the endless rush. Models begin to test how such a craft might move. A natural object, like a small asteroid or comet fragment captured by Saturn, would follow a stable orbit. Its motion would be predictable, its path a clean curve governed by gravity alone. But what if something nudged that path now and then? Analysts play with simulations where a tiny mass no larger than a modest spacecraft glides from moon to moon, using gravity assist the way human probes already do. A close pass by Titan to change trajectory, a brush near Enceladus to tilt. The orbit, a slow drift along the ring plane to stay hidden. On the screen, the path looks like a quiet dance. Curve, swing, glide, repeat. They know this pattern well because human engineering has done similar things. Probes have already borrowed gravity from planets, using flybys to gain speed without burning fuel. A spacecraft sent to the outer solar system might loop around Jupiter or Saturn, each pass bending its trajectory like fingers guiding a spinning coin. In the Saturn Fortress idea, an advanced object could be doing the same thing, only with more finesse, sliding through small gravitational corridors, weaving between moons, always keeping itself in places where telescopes find it hardest to see. It would not need to be fast or flashy. It would only need to be patient. Timeless. As the models run, the team also considers line of sight. From the vantage point of Saturn, a craft positioned at the right orbit could have a clear view inward. Earth, Mars, even the inner planets tracing their own paths around the sun. The bright disk of our star would sometimes hide these worlds, but at other times they would appear like tiny points against the dark. From this balcony, the watcher could see more than one world at once, measuring changes in our radio output, our radar, the soft glow of our cities at night. It would be like sitting high on a quiet ridge, looking down at the lights of a valley town below. If such a probe wanted to speak, even in the faintest way, it might use the shield of the rings to do it. A narrow beam of energy, aimed precisely, could skim along the ring plane, bouncing and scattering just enough to blend into the constant background noise. When telescopes point at Saturn to study its atmosphere or ring structure, that extra pattern could slip into the data. Most days, it would be lost in the flood. But on a few rare passes, When the angles align and a spectrograph is tuned just right, the pattern might stand out, a repeating anomaly in the cradle of silence. A cosmic whisper hiding inside a roar. Of course, the scientists remind themselves there are less exotic explanations. The same gravitational corridors that could guide a craft also guide natural debris. The same ring haze that could hide a probe also scrambles the light from countless particles and tiny moons. The fortress might be no more than a poetic metaphor for a messy region of space where instruments naturally struggle. The anomalies might come from dust storms in the rings, from charged particles in Saturn's magnetic field, or from some interaction between solar wind and ice that no one has described yet. The fortress might be real, but built entirely by nature.
Clear the water line.
Still, the idea lingers because it fits something deep in human
Raising the
memory.
load now.
Throughout history, people have imagined watchers in high places, beings on mountaintops, gods in the clouds, sentinels on distant hills. Now, those stories play out on a cosmic scale. Saturn becomes the mountaintop. Its rings become the walls of a hidden citadel. The unexplained signal becomes a possible messenger leaning on that balcony, looking outward and inward at once. Is it a harbinger, an omen, or simply another reminder of how much remains unknown? The question alone is enough to stir quiet awe. If you were to step outside on a clear night and look up, you would not see this fortress with your own eyes. Saturn would be a faint point, maybe a steady dot of pale gold. Yet, knowing that scientists are drawing invisible maps around it, tracing orbits, marking possible hiding spots, changes how that dot feels. It stops being just a faraway planet and becomes a place with structure and shadow, with corners where something could remain hidden for years. You stand under that sky, feeling small, and yet touched by the idea that someone might be watching from those distant shadows, or that one day we might be the ones hiding probes around other worlds in the same way. In the end, the Saturn fortress hypothesis remains what it began as, a thought experiment, a dream laid gently over a bed of hard data. No telescope has yet glimpsed a solid object matching the models. No spectrograph has traced a perfect line back to a visible craft. The signal is still only a pattern in the noise, a fragile hint of something that might be more than it seems, or might not. But as the simulations run and the ideas swirl, Saturn's neighborhood takes on a new character. It ceases to be just a distant ringed planet and becomes a possible balcony over our solar system, a place where the boundary between known and unknown grows wonderfully thin. And somewhere in that thin space, between icy rings and drifting moons, the imagination pauses and listens. The signal may be nothing more than a quirk of nature, a memory of some passing comet or tumbling rock. Or it may be the first faint echo of a presence that has chosen Saturn's fortress as its quiet lookout. For now, the mystery remains suspended there, like a drifting shadow in the glow of the rings, waiting for sharper eyes, better ears, and the next small step toward understanding. In the soft darkness beyond Saturn's rings, the moons begin to appear one by one, like lanterns hung around a distant harbor. Some are tiny and sharp, little points of light against the endless night. Others are large enough to hold on to an atmosphere, to wear clouds, to hide oceans under ice. Tonight, the camera of the mind glides past them slowly, as if you were a quiet passenger in a ship drifting through a cradle of silence. Closest in this journey is Titan, Saturn's great moon, wrapped in a thick orange haze. Through the soft veil of its atmosphere, starlight turns to a smeared, gentle glow. Orbiters and telescopes have watched Titan for years, tracing its orbit, measuring its cold, heavy air, and mapping dark shapes on its surface that are not craters. But those lakes do not shine with water. They are made of liquid methane and ethane, hydrocarbons collecting in basins like pools of frozen fuel. Yet from far away, they behave in familiar ways. They ripple, they evaporate, they rain back, down. The reflected starlight off these alien seas becomes a shimmering map, each lake a quiet mirror holding a fragment of the sky. Imagine standing on a cliff at Titan's shore. The air is thick, the cold is deep, and the sky is heavy with haze. No wind roars. It only murmurs, a low whisper moving across the orange clouds. The methane sea below you is almost still, its surface catching the faint glow of Saturn's rings far above. It feels like the ultimate secret harbor, a place where something could anchor, watch, and wait beneath the gentle veil of mist. Farther out, the path bends toward Enceladus, small and bright, a fragment of ice shining in the dark. From a distance, it looks simple, a smooth bead of white. But as the imaginary ship draws closer, thin jets appear, rising from long cracks near its south pole. These plumes of water and vapor spray into space like icy geysers, each one lit by distant sunbeams, turning into a brushstroke across the sky. Real spacecraft have flown through those plumes, sampling particles as they sped past. Inside, they found hints of salt, organic molecules, and warmth signs that beneath the frozen shell, there may be a hidden ocean, deep and dark. In that hidden sea, heated by tides and rock, some scientists believe the ingredients for life could swirl together, slow and patient, like a dream that has not yet decided whether to wake up. The scene around Enceladus is strangely alive. Tiny ice grains fall back like drifting snow. Some escape into Saturn's orbit, feeding the E-ring, a faint halo of frozen dust that wraps around the planet in a thin, luminous haze. The solar wind slides past, shaping the cloud of particles, carrying a soft, invisible current through the region. If you listen in your imagination, you might hear a steady hiss, like distant rain on a roof. As particles strike instruments on passing spacecraft, other moons circle nearby, each with its own story. Mimas, with its giant crater, looks like an ancient traveler scarred by a single enormous impact. Dione and Tethys drift like pale marbles, their surfaces etched with fractures and valleys. Rhea moves in a cold, slow orbit, a fragile shell of ice under the watch of Saturn's rings. Over all of this, the instruments we build continue to watch. Orbiters once traced paths that took them through these moon systems again and again, mapping gravity, measuring composition, searching for anomalies that did not belong. James Webb does not fly here. It sits far away near Earth, but it can still turn its great mirror towards Saturn's region and study how starlight and infrared glow pass through this complex scene. In this chapter of the story, telescopes become travelers not by moving their bodies, but by moving their gaze. Engineers and scientists overlay the silent signal near Saturn onto a map of orbits and paths. Lines are drawn where Titan moves, where Enceladus arcs, where other moons trace their invisible lanes through space. They ask simple questions first. Does the timing of the signal match any moon's orbit? Does it peak when Titan crosses a certain position, or when Enceladus plumes face a particular direction? Does it brighten when a comet briefly shares the same region? The answers, for now, are quiet. Some nights, the signal seems strongest when Titan is high in its orbit, as if the giant moon and the anomaly share a secret alignment. On other nights, it hums faintly during Enceladus passage, as though the hidden ocean under the ice is somehow involved. But then there are times when neither moon is in a particularly special place, and the signal is still there, whispering softly in the data, like a guest who refuses to leave to sort truth from coincidence. The teams turn to more detailed tools. Spectrographs examine the faint background glow around Saturn and its moons, looking for tiny changes in color, a hidden line here, a missing line there, that might suggest something unnatural. Software filters trace the signal's rise and fall while accounting for every known satellite, probe, and piece of human hardware in orbit. Radio dishes on Earth listen too, their broad metal surfaces turning slowly in the night as if they were ears cupped toward the sky. Through it all, the environment around Saturn remains calm. In your mind's ear, you might hear the soft gasp of Enceladus geysers, the almost silent rush of particles spiraling along magnetic field lines, the faint tick of instruments counting impacts of ice and dust. Only a possible cosmic whisper replays at its own pace. Indifferent to our urgency, the idea begins to grow that these moons are not just places, but potential harbors for more than rocks and ice. A hidden probe could tuck itself into Titan's thick atmosphere, masked by haze and hydrocarbon clouds. It could drift under those orange skies like a moving shadow, its own signal folded inside the natural radio noise of storms and static. Around Enceladus, another device could rest in the ring of ice grains, using the constant snow of particles as a shield and cover. Or perhaps nothing artificial exists here at all. Perhaps the harbors are entirely natural, warm pockets in subsurface. Oceans, mineral-rich vents at the bottom of dark seas. Places where simple life, if it ever formed, clings to rock and heat while the surface remains frozen and still. The signal might be a pattern made by fields and flows inside a moon that behaves like no other in the solar system. As these ideas swirl, the story slows again, returning to the simple image of Saturn and its moons hanging in space. Titan's lakes reflect a distant, diffuse glow. Enceladus paints thin white lines into the dark. The smaller moons move like silent escorts, keeping their careful distances as they follow trajectories set long before any telescope ever turned their way. The entire system looks like a vast, timeless port where ancient travelers might one day dock. Somewhere within this scene, the unexplained signal continues to appear and fade, as if breathing. It may be nothing more than a strange rhythm in the way particles and fields interact. It may be the mark of a hidden ocean's restless heart. Or it may be something else entirely, a quiet messenger anchored in the cold, watching and transmitting. In a way we hardly know how to read. For now, the question remains open, like a door left slightly ajar. In the hush of this distant harbor, under rings and ice and drifting dust, it is easy to imagine that something waits. A probe powered by a patient mind, a pattern written in frozen seas, or a memory buried so deep in ice that only careful listening can bring it back. And in that gentle uncertainty, the wonder lingers, suspended in the endless night around Saturn's silent moons. In newsrooms across the planet, the first reports arrive quietly. A new anomaly in the sky, a strange signal near Saturn. At first, it is just a line in a script, a small headline on a screen. Yet even in that small space, the words "possible extraterrestrial source" sit like a spark in dry grass. A producer leans closer to a monitor. A writer rewrites a sentence, making it softer, more careful. The night outside the studio windows is dark, but inside, the light of the screens paints faces in a pale, restless glow. In one control room, a red tally light glows above a camera. A presenter smooths their notes and looks into the lens as the director counts down. Behind the glass, editors shuffle between feeds. Images of Saturn's orbit, a graphic of radio waves, footage of the James Webb Space Telescope unfolding like a silver flower. The tone is measured, almost sleepy. Scientists have detected an unexplained signal near the ring planet Saturn, the presenter says. They stress that there is no reason for alarm. The word alarm lands a little heavier than planned. On couches and in bedrooms, people watch from home. You can imagine yourself there too, half lying under a blanket, the volume turned low. A lamp throws a soft glow across the room, while the TV shows a slow animation of the solar system. Planets moving on careful trajectories. For a few seconds, the ordinary world pauses. The upstairs fan hums. A refrigerator clicks on in the kitchen. Outside, traffic moves like a distant ocean. Inside, one phrase hangs in the air, an unexplained signal. When the word extraterrestrial appears at the bottom of the screen, wrapped in cautious language, something old and timeless wakes in people. For some, there is wonder and hope. They picture a friendly messenger, a distant civilization, reaching out from beyond the cradle of silence, sending a cosmic whisper to say, "You are not alone." They think of exoplanets circling distant stars, of blue worlds and golden clouds, of lights rising over a far-off ocean. For others, there is a thin, sharp thread of fear. They hear the same story and feel a different echo. The signal sounds like a warning, a harbinger of something unknown drifting toward us. Their minds jump to hidden fortresses in the dark, to omens from the sky, to stories where visitors do not come in peace. The telescope shot of Saturn's rings, beautiful and calm, begins to feel like a stage where something else might be hiding just out of sight. In living rooms, families react in different ways. A child asks, "Does this mean aliens are real?" A parent answers carefully, explaining that scientists use words like anomaly and unexplained when they are still trying to understand. A teenager scrolls on their phone, finding clips, comments, jokes, and frightening edits that turn the signal into a prophecy. Someone changes the channel. Someone turns up the volume. Someone, in a small apartment, lit only by the TV's glow, just sits in silence and listens. The internet becomes its own kind of telescope, focused not on Saturn, but on us. Timelines fill with theories, images, and memories. People remember where they were for past moments of cosmic excitement. When a comet streaked across the sky, when images of a distant comet landing filled the news, when a supernova's light reached Earth after traveling through space for ages longer than any human memory. Each event felt like an ancient traveler passing briefly through our shared story. The tone of the world is mixed, like layers of a nebula, threads of awe, patches of worry, pockets of calm. Some posts celebrate the beauty of the universe, sharing pictures of the ringed planet under a gentle veil of starlight. Others warn about unknown dangers, speaking of secret projects, hidden messages, and forbidden patterns in the data. Between them, quiet voices ask simple questions. What does it mean? Will this change anything? Or will it fade like so many stories before it? In late-night radio shows and podcasts, hosts speak in low voices as callers share how they feel. A truck driver on an empty highway says the news makes the road feel different, like the sky above him is wider and more crowded. A nurse on a break outside a hospital looks up at the faint shimmer of stars beyond the city glow and wonders if someone out there is looking back. A student on a dorm rooftop listens to the story and feels both small and strangely connected. To everyone else who's hearing the same words at the same time, there is comfort, too, in the pattern of our reaction. We have been here before, standing under the same endless night, watching comets, eclipses, and strange lights. For centuries, people have looked up and filled the darkness with meaning. They saw omens in meteor showers, messages in the wandering of planets, signs in the way starlight flickered through clouds. Now we have spectrographs and spacecraft, telescopes that can see galaxies and exoplanets, but the feeling is much the same. The sky changes, and so do we. Scientists, of course, are not immune to these feelings. They grew up under the same sky. Many of them chose their path because of a comet they saw as a child, or a picture of a nebula pinned to a bedroom wall. When the first alert about the Saturn signal appears in their inboxes, they feel that same mix of awe and caution. But in the quiet that follows, training takes over. They know that wonder alone cannot answer a question in laboratories and offices. In observatories perched on desert mountains and frozen plains, the human reaction shifts from feeling to focus. Screens are rearranged. Data from other telescopes are requested. Logs of satellite passes, asteroid trajectories, and instrument tests are pulled up and examined. The signal may be a messenger from far away, or it may be a trick of noise and timing, but either way, it must move from story to study. Outside these rooms, the world continues. Lights switch off one by one in city apartments as people drift towards sleep, carrying quiet questions with them. Was today the day we first heard from someone else? Or was it just another strange echo in the long, patient song of the universe? On a planet turning through space, billions of dreams unfold under the same sky that holds Saturn, its rings, and the faint, hidden source of the anomaly. In the end, the first wave of emotion settles into something slower and deeper. Wonder and worry soften into curiosity. The headlines shrink, but the work does not. In the calm that follows the rush, scientists return to their instruments and their models, to their equations and their maps of orbit and light. Somewhere in the quiet layers of their analysis lies the next step, the next small clue to what this signal really is. And as the world sleeps, a simple, fragile thought drifts through the cradle of silence that surrounds our planet. When the feelings fade and the screens grow dim, what path will careful minds choose to follow in the search for truth hidden within that distant, persistent whisper? In the days after the first excitement, the mood around the signal changes. The shouting headlines fade. The social media storms slow down. What remains is something quieter, more careful, like the low murmur after a thunderclap. Beneath this, calm, a different kind of meeting begins. It does not happen in a single room, or even on a single continent. It unfolds in deserts, on mountaintops, beneath domes of glass and steel, and in orbit above the Earth. Telescopes, spread across the planet and beyond it, begin to turn their attention toward the same patch of sky near Saturn, as if answering a silent invitation. Far from city lights, a radio telescope array waits under a dark, endless night. Its giant dishes sit like sleeping giants, each curved surface catching a soft glow of starlight. Engineers in a control building send commands, and the dishes slowly pivot together, their motion smooth and patient. They lock onto new coordinates, adjusting for Earth's rotation, for Saturn's orbit, for the exact place where the anomaly first appeared. In the gentle hum of electronics and cooling fans, the cosmic whisper from that direction becomes their focus. Here, people do not talk about aliens. They talk about signal strength, trajectory, timestamps, and how to make sure nothing nearby, no plane, no satellite, no stray burst of interference can trick them. On a high mountain peak, an optical telescope joins the quiet gathering. Its white dome opens like an eye. Inside, mirrors polished to a near-perfect shine tilt toward the same region near Saturn. Thin, cold air slips past the structure as the telescope begins its slow, precise dance. The observers are not expecting bright fireworks or glowing ships. They know that if anything is there to see, it may appear only as a tiny shift in starlight, a faint change in the way Saturn's rings reflect the sun, or a drifting shadow near a moon's edge. Still, they capture long exposure images, letting the camera soak in every photon, every flicker, as if they are collecting the brushstrokes of an invisible hand across the sky. High above Earth, in the cradle of silence where the atmosphere fades into space, other instruments are already at work. Space telescopes tuned to infrared light watch the region with patience. In that part of the spectrum, heat becomes visible. The glow of dust, ice, and rock reveals patterns hidden behind a gentle veil of ordinary starlight. Data streams down to Earth. Temperatures, spectra, tiny changes in brightness over time. In a dark operations room, teams look for anything that moves in a way it should not, something that does not follow the simple, predictable path of a comet or asteroid gliding along its natural orbit. On screens around the world, lines of different colors begin to pile up. Radio readings, infrared readings, visible light images. A few ultraviolet and X-ray observations join in, just to be safe. Scientists layer these different kinds of data like transparent sheets of glass, stacking them on top of one another. Where most sheets show nothing special, a few points line up across them, small but persistent, like the same faint note repeating in a much larger song. The signal from near Saturn is not loud, but it does not vanish. Night after night, it appears again where the telescopes are listening. Inside meeting rooms, some real and some virtual, the human side of the secret meeting unfolds. Monitors glow against tired faces as teams from different observatories share their results. Someone in a quiet office in Europe pulls up graphs from a radio array in the Americas. A researcher in Asia compares them to optical data from a southern hemisphere telescope. A mission specialist tied to a space observatory offers timing checks and orbit details. Their voices are calm, their language precise. Correlations, error bars, confidence levels. Yet under every sentence lies a feeling of quiet awe, as if each person knows they might be hearing the same distant messenger. Radio specialists talk first, showing how they have filtered out familiar noise. Signals from satellites in low Earth orbit, reflections from aircraft, even strange echoes from ground-based transmitters. All these are removed with steady, careful work. What remains is a narrow, repeating structure that seems to come from far beyond the sky you see when you look up at night. Not from a nearby tower, not from a passing plane. It arrives with a timing that matches the long path between Saturn's domain and Earth, a fragile thread stretched across hundreds of millions of miles. Then the optical and infrared teams step in. They show light curves, simple plots of brightness over time for objects near the signal's apparent source. They track the motion of known moons, asteroids, and small bodies, checking their trajectory against the signal's appearance. If a comet passed nearby, its dusty tail might change how starlight looks. An asteroid might cause a brief dimming as it crosses a background star. But again and again, known explanations glide past, leaving the anomaly untouched. The light behaves the way it always has. Saturn and its moons continue their ancient dance, their orbits steady and calm. Spectrograph data add another layer. These instruments break light into its colors, turning a beam into a band of lines that can reveal what elements are present: hydrogen, helium, methane, water, ice. They have uncovered the signatures of distant nebulae and exoplanet atmospheres, subtle clues of chemistry in far-off places. Now, they are trained on the space near Saturn, searching for any unusual spectral fingerprint that might hint at a cloud of gas, a plume of ice, or a hidden source of energy. The spectrographs report only what is expected: cold space, faint reflected sunlight, no obvious harbinger blazing in the dark. Slowly, a picture begins to form, not of what the signal is, but of what it is not. It is not a glitch in a single instrument, because multiple telescopes see its timing. It is not a passing meteor in Earth's sky, because the geometry is wrong. It is not a burst from a nearby satellite, because the direction and delay do not match. Every time a likely culprit is tested, the anomaly stands apart, a small fortress of unexplained pattern in the middle of a wide sea of data. Skeptics in the group are not pushed aside. They are invited to push harder. They are asked to be the storm that tries to wear this little fortress down. Days turn into weeks. The world outside continues with the rhythms of daily life, traffic, weather, laughter, and worry. Inside the quiet halls of observatories, the rhythm is different. Each new observing window offers another chance to test the signal. If it appears again at the expected time from the expected direction, the confidence grows. If it shifts the way a source in orbit near Saturn might shift, that too becomes part of the story. If it fades or breaks apart into random noise, then the dream dissolves. For now, the anomaly persists. It remains a steady visitor in the logs, a familiar spike among lines of static dot to you as a listener drifting towards sleep. This meeting of telescopes may feel almost like a dream itself. You can imagine wide radio dishes under a star-filled sky, their curved arms pointed toward a planet you cannot see with your own eyes. You can picture a telescope dome opening on a cold summit, faint starlight sliding down onto a mirror like water spilling into a bowl. You might even see the Earth from above, dotted with glowing control rooms, all hooked together by invisible links of data and intent. Across these great distances, people who will never meet face-to-face are quietly united by a single unexplained pattern. In the end, the secret is not really a secret at all. It is a careful, almost fragile conversation between instruments and minds. The telescopes do not vote. They do not shout or make claims. They simply listen and report. Humans add meaning. They are the ones who look at a repeated pattern and ask if it might be a messenger or just another trick of the universe's deep, complex noise. They are the ones who feel the tug of hope and the weight of responsibility at the same time. As the graphs fill with more and more lines and dots. As the logbooks lengthen and the spreadsheets grow, one fact remains. The pattern has survived. Every test so far. It still stands there, slim and quiet, in the tide of static that washes through every telescope on Earth. It could yet crumble under some future check. Some clever new filter, some better understanding of Saturn's neighborhood. But for now, it endures small, steady, and strangely dignified. And so, as night falls again over deserts and mountain peaks, the dishes and domes hold their vigil. The signal is not loud. It is not dramatic. It is simply there, like a faint light left on in an upstairs window of an ancient house at the edge of town. No one knows yet who, if anyone, is inside. No one knows what the light means. But in the drifting quiet between stars and instruments, the pattern remains, a silent fortress in the noise, carrying with it the soft suggestion that something, somewhere, is waiting to be understood. The question hangs in the dark like a small lantern over a quiet road. What exactly is this thing we have found? The signal near Saturn sits in the data, steady and patient, while minds on Earth try to give it a name. Before anyone even thinks the word artificial, the first duty is simple and honest. Ask if nature, in all its strange creativity, can explain it. The search begins with gravity itself. Far beyond Saturn's orbit, black holes twist space-time and bend the path of starlight. Sometimes their pole can focus distant bursts of energy toward us, acting like a cosmic magnifying glass. Analysts ask, could a far-off black hole, hidden behind a nebula or a galaxy cluster, be warping some flare into this repeating anomaly? They look at the trajectory of the signal, its timing, its faint strength. The pattern is regular, but not in the way black holes usually drum against the background sky. So this idea quietly fades. Attention turns to pulsars, spinning corpses of stars that flash like lighthouse beams in the night. A pulsar's steady spin sends out pulses with clock-like precision. The signal from these ancient travelers crosses the galaxy like a slow, patient metronome. The team compares the Saturn anomaly to catalogs of known pulsars using telescope data and old recordings. They check its period, its shape, how sharply it rises and falls. It is close to some, but not the same. It feels like a song that almost matches a melody, but slides just a little off key. Past records remind them that not all pulsars behave. Some glitch, some slow, some flicker as if something inside them is shifting. Still, when they run the data through models, the match is never clean. The curves do not overlap quite right. The timing drifts in the wrong direction. It is as if the universe is saying, "Nice try," and then quietly turning the page. Next comes the thought of comets and their long, cold journeys. A comet is an ancient traveler too, circling the sun on a stretched orbit. Its perihelion bringing it close before it drifts back into the dark. When comets approach, they grow tails as ice turns to gas and solar wind pushes that gas into glowing streams. Could the signal be the result of a comet tail interacting with charged particles, creating a repeating flicker like a heartbeat? The team traces known comet paths near Saturn, checking their position when the signal appears. Simulations fill screens with shimmering arcs and drifting shadows, dust moving along invisible lines. The models are beautiful, but again, the timing does not line up. The heartbeats in the data and the paths of the comets refuse to match. They consider supernova echoes as well. When a star explodes, it sends out a wave of energy that can bounce off clouds of gas and dust, arriving much later like a faint echo in a canyon. Somewhere far beyond our solar system, a supernova once lit the sky in silent violence. Its light may still be reflecting through space, brushed across clouds and hidden pockets of dust. Scientists ask, could this signal be one of those echoes focused by some patch of gas or the edge of a galaxy cluster? They compare its frequency with known remnants, using spectrographs to read which elements might be involved. The signature is unusual, not impossible, but awkward. Like a glove that almost fits a hand, yet leaves the fingers bare. Meteor streams and asteroids offer other paths. Around Saturn and all through the solar system, tiny stones and grains of dust move along ancient lanes. When a meteor stream crosses magnetic fields or solar wind, it can create a flicker of energy. Perhaps the signal is nothing more than nature's static, produced as particles rush along their orbit. Models of meteor density and speed are run. The resulting patterns look messy, irregular, noisy, a far cry from the smooth, repeating structure of the anomaly that sits near Saturn like a calm, steady tick at the edge of the cradle of silence. Each time a hypothesis appears, it is weighed gently. Could this be the wake of a hidden rock tumbling along a tilted path? Could it be a lensing event, where a small object bends a distant beam just enough to create a fake rhythm? Could it even be something inside the telescope? A subtle dance of electronics and cooling systems? Investigators cross-check readings from other instruments. They compare them with data from other telescopes watching the same slice of sky. Quietly, patiently, each simple answer is tried and set aside. None of this is rushed. In control rooms and offices, people speak in calm voices, aware of how fragile moments like these can be. Coffee cools beside notebooks. Screens glow softly in the dark, showing graphs and faint lines of code. They remember times when the word anomaly turned out to mean, oops, that was just us. They hold that memory close, not wanting hope to run ahead of truth. The signal is treated with respect, not because it must be a messenger or harbinger, but because the universe rarely gives up new secrets without a long, slow conversation. As the natural options thin out, another thought creeps in. What if the list itself is too short? Human knowledge sits on a tiny island in a vast ocean. Black holes, pulsars, comets, meteor streams. Supernova, these are the words we have written so far, the categories we teach in school. But the cosmos does not care about our labels. There may be kinds of objects we have never seen, kinds of physics we barely touch at the edge of our equations. The team begins to wonder if the signal belongs to one of these unnamed categories, a phenomenon so new that it does not fit any familiar box. Only then, at the edge of that realization, does the question of intelligence begin to glow faintly, like a distant star rising over a horizon. If you are listening to this, You can almost feel that shift, the moment when a group of careful scientists has to admit that we don't know is now the most honest answer on the table. Does that mean artificial? No, it only means the field is open, and the night just became a little larger. To call something artificial is to say it bears the mark of intention. Artificial means made, shaped, chosen. Nature can be complex and surprising, but it does not choose. It simply follows its laws. So what would a truly artificial pattern look like, far from any obvious home? Would it be as simple as counting 1, 2, 3 impulses across the dark? Would it carry a map, a path, a hint of orbit encoded in its timing? Or could intelligence elsewhere be so unlike us that even its greeting looks like an ordinary flicker in our sky? These are not questions anyone can solve in a single night. They linger at the edge of the mind as the signal runs on, steady and quiet. In the soft glow of the lab, graphs stretch across screens like faint landscapes. Peaks and valleys rise and fall in a slow, measured way. Somewhere in those lines, there may be a story. Natural, artificial, or something we do not yet have words for. For now, the team chooses patience. They keep watching. They compare old data with new, looking for earlier traces of the same pattern. They search other parts of the sky, testing whether this is a lone anomaly or one member of a hidden family of signals. Every empty patch of sky adds to a strange feeling of awe. Whatever this is, it is not easy. It does not volunteer its nature. Out beyond Saturn, the source, whatever it may be, continues on. Maybe it rides the orbit of some unseen companion, or drifts in the solar wind like a small, silent buoy. Maybe it is fixed, anchored in the dark, throwing out a steady cosmic whisper that only now brushes against our listening instruments. Down here, under our own thin air, humans do what they have always done when faced with the unexplained. They give it space, they give it time, and they let their curiosity breathe. In that breathing room, a gentle truth settles in. Not knowing is not a failure, it is a doorway. On one side lies everything we have already named. On the other is a field of possibilities, some natural, some artificial, some still unimaginable. The signal stands at that doorway like a quiet sentinel, asking nothing, explaining nothing, simply existing. And as the night goes on, the question that started as a technical puzzle becomes something softer and deeper. Not just, what is this? But what else might be out there, waiting behind the next thin veil of noise? In the drifting quiet, the anomaly remains, and with it, the sense that the universe holds more categories than we have dreams yet dot out in the dark beyond Saturn's soft glow. The signal continues to pulse like a tiny heartbeat in the cradle of silence. The instruments see it as digits and graphs, thin lines running across a screen. But in the quiet of the control room, it feels like something else, a cosmic whisper, a knock on the edge of our orbit asking, very softly, to be noticed. Astronomers still call it an anomaly, an unexplained pattern near the ring giant. Yet beneath that calm word, another thought slowly unfolds like a drifting shadow. What if this is not only a pattern in noise, but a messenger? If the signal is a message, then somewhere there is a mind behind it. Not a face we recognize, not a voice made of breath and vocal cords, but a pattern-making mind that chose repetition over random chaos. Imagine, for a moment, a lonely outpost on a distant exoplanet. Its sky is tinted by a different sun, maybe copper or violet instead of blue. A pale star hangs low in an endless night, wrapped in a gentle veil of nebula light. On that world, a small group of beings gathers around their own telescope, tuning a spectrograph to listen for the faint echo of starlight and hidden signals drifting through the dark. They study our sun from far away, seeing it as a soft glow in a distant patch of sky. They trace the tiny wobbles that betray the presence of planets, mapping our orbit as we circle once more around our star. They know nothing of our cities or oceans, only that this system is not empty. For them, Saturn is not a picture in a textbook. It is an ancient traveler circling a yellow star, wrapped in rings of dust and ice. To a careful engineer on that world, those rings look like the perfect place for a quiet relay, a natural fortress in our solar system's outer suburbs dug in that distant control room. Lit by a different kind of daylight, they decide to send signal. Not a shout that floods the sky, but a whisper that barely rises above the cosmic background. Not something aimed directly at Earth, but a quiet, repeated pattern directed toward the region near Saturn, where a small probe can drift and watch. Their messenger craft slips into our system over many years, riding a carefully planned trajectory, bending its path around comets and planets, using gravity as a guide. It settles into the ring plane, hidden in the luminous haze of ice and rock, and begins to transmit. No voice, no words. Just the same sequence again and again, like ripples spreading from a single stone dropped into a still lake. Encoding a message is both science and art. Here on Earth, our first attempts tried to be as simple as possible. Pulses that count prime numbers, patterns that draw pictures in binary, a human shape, a map of our solar system, a diagram of hydrogen and carbon. To us, these designs are basic, almost childlike, our first handwriting on the wall of the universe. To another mind, they might be beautiful or confusing or invisible. In the same way, the signal now flickering near Saturn could be built from building blocks we barely recognize, using shapes in time instead of shapes on paper. Perhaps it uses timing instead of tone, like a cosmic Morse code that relies on gaps rather than bursts. Perhaps the important part is the spacing between pulses, the rhythm rather than the loudness. It might ride on a carrier hidden in frequencies our older radio telescopes never bothered to check. It doesn't have to be loud like a supernova or bright like a comet near perihelion. It could be more like patterns in a sand dune, delicate, easy to erase, but full of meaning if you know how to read the ridges and lines. On some distant shore, a child might draw circles and lines near the edge of the sea, letting the waves wash away everything but the memory of what was there. In space, a patient civilization could let solar wind and drifting dust erase most of what it sends, trusting that somewhere, once, a careful eye will catch the design. The James Webb Space Telescope is such an eye. Its mirrors, tuned to detect the faint heat of distant galaxy clusters and exoplanets, might also be catching the thin brushstroke of a message meant to be barely there, just enough to rise above the background, not enough to disturb the cosmic quiet. Think of repetition as a universal greeting. Hearts beat in rhythm. Planets keep steady orbits. Even a pulsar, a collapsed star spinning in the dark, sends out a regular pulse like a lighthouse in space. If another mind wanted to show it understood order and time, it might choose a pattern that cannot be mistaken for random noise. A sequence that feels like counting, like footsteps, like breath. To some on Earth, the Saturn signal is already described this way, not as speech, but as a clock. Not telling us what to do, not demanding a reply, only quietly saying, someone is keeping time out here. Now, imagine a different story. A timeless culture that has known our solar system for longer than our species has walked on land. To them, Saturn's rings are not just a beautiful sight. They are a tool. Wide, bright, and visible across the system, they offer both a stage and a hiding place. A small device, nested among icy fragments, could orbit unnoticed for ages. It might wake at long intervals, once every few years, once every orbit of some distant comet, and send a gentle signal that only the most sensitive instruments could hear. From Earth, we see only the result, a repeating anomaly near Saturn's position, steady despite the constantly shifting chorus of asteroids and meteors. From their point of view, perhaps it is just routine, a lighthouse they lit long ago and never bothered to switch off. And then there is the most haunting possibility, the Watcher. Not a busy station full of voices, but a single automated sentinel. No one left at home, maybe. Only a memory encoded in hardware and software, left behind when its makers moved on or faded away. The Watcher circles Saturn in a stable orbit, powered by light and slow radioactive decay, patient beyond any human lifespan. Its purpose is simple and unchanging. Listen. If anything stirs a rocket plume, an unexpected radio burst, the warm glow of a new telescope peering its way send a signal to mark that this system is no longer empty. In that quiet tale, the signal is not a greeting, but a log entry. A short line in a ledger that spans centuries. It doesn't say, "Hello." It says, "Noted, someone is here." That idea carries its own mix of awe and unease. To be noticed is to exist in someone else's record. To be logged is to join a story you did not write. Even if the Watcher has no one left to report to, the act of recording changes the meaning of our presence. We are no longer alone in our own narrative. We have become a small detail in another civilization's long memory. As you listen, you might picture this Watcher as a small craft drifting just above the ring plane, its surface coated in dust, its body a fading shade of gray against a gentle veil of ice below. Starlight glints in dull flashes as it moves, invisible to human eyes, its thin antenna barely outlined against the soft glow of Saturn's limb. Inside, data shifts through simple circuits, repeating the same encoded rhythm we now see as a strange, steady pattern just beyond the giant planet. The work of decoding such a message would be slow and patient. Teams on Earth would stretch the signal out along a timeline, looking for structure, repeating groups, mirrored sections, places where the pattern breaks in ways that feel deliberate. Spectrographs would examine not just how strong the signal is, but its color, its subtle drift with Saturn's orbit, its response to solar wind. Computers would try guesses. What if each pulse is a 1 and each silence a 0? What if the message is grouped in 8s and 12s in prime numbers? Each model would appear on screens like abstract art dots and lines, blocks and gaps waiting for meaning to emerge. The beauty of the question lies in its uncertainty. We do not know if the signal is a message at all. It could still be something natural, a strange interaction between rings, moons, and magnetic fields making a rhythm we have never seen before. Yet even that possibility feels like a kind of message from the universe, itself reminding us that there are still forces and rhythms in our own solar system that we do not fully understand. The cosmos may be speaking in dialects we are only just beginning to hear. If it is a message, it changes us long before we translate a single bit. It gently pushes us out of the center of our own story and places us on a wider map, just one fragile point along a vast trajectory. It makes us ask what we would say in return if we decided to speak back. Would we answer with math, with music, with a simple repeating pulse that says, "We hear you"? Or would we remain a drifting shadow, listening but unseen, adding our own silence to the cradle of silence already wrapped around Saturn? For now, the signal continues calm, steady, and unexplained somewhere beyond the ring giant's soft glow. Its meaning remains hidden, its sender unknown. Yet, in the quiet, between each pulse, in the narrow spaces where no data appears, there is room for our awe, our fear, and our hope. There, in that gentle pause, the possibility of connection lingers like a faint light on the horizon, fragile, timeless, and waiting, somewhere in the endless night. To be understood, in the quiet hours of the night when most of the world is asleep and only a few windows glow, a different kind of question hangs in the air. Somewhere beyond Saturn's pale rings, an unexplained signal waits in the dark, a steady cosmic whisper against the endless noise of space. On Earth, in calm conference rooms and soft-lit offices, people are asking something simple but heavy. If this is a messenger, should we answer? The debate is not new. For years, scientists, writers, and dreamers have argued over the idea of messaging extraterrestrial intelligence, METI, the cousin of SETI, which only listens. Where SETI aims telescopes at the sky and waits quietly, METI wants to speak. Imagine sending our own voice out into the cradle of silence to see if anyone replies. Some say we already have. They point to early messages, radio pulses sent from powerful dishes, shaped into patterns that sketch our place in the galaxy. Spacecraft like Voyager and Pioneer left Earth on long trajectories, carrying plaques and golden records with music, greetings, and the soft imprint of our time. These were lanterns lit in an unknown valley, drifting outward like ancient travelers through the dark. Others answered that those efforts were more like postcards than beacons. They argue that our planet already shines with radio and TV waves leaking into space for almost a century. Any nearby exoplanet with a sensitive spectrograph could, in theory, see the flicker of our technology in the glow of starlight. From that point of view, the signal is already out there. We have been speaking without meaning to, but METI goes further. It asks, what if we choose to call out on purpose? What if, instead of a faint accidental leak, we send a strong, focused message into the sky? A message aimed like a lighthouse beam, not just a drifting shadow? It is here that the debate sharpens, even as the voices stay calm and careful. Those in favor of replying look at the Saturn signal and feel wonder before fear. To them, the universe is not a hostile fortress, but a vast, ancient ocean where islands of life are scattered and lonely. If another mind has placed a messenger near our rings, they say, it is sad to pretend we never heard it. They picture a civilization that waited for ages, watching tiny worlds form and spin in orbit, hoping that one of them would wake up and answer. To them, a reply is an act of hope. They also argue that any species able to send a clear signal across interplanetary or interstellar distances already knows we exist. Our atmosphere has carried the marks of life for billions of years. The oxygen, the fingerprints of plants, the warmth of cities seen from orbit. These are like signatures written across the sky. We are not hidden, they say. The secret is already gone. On the other side, caution speaks in a softer, but no less certain, voice. These thinkers reach for the metaphor of a dark forest. Imagine, they say, standing in a strange wood at midnight. You cannot see who else is there. Some travelers might be kind. Others might be frightened. A few could be dangerous. In such a place, lighting a bright fire and shouting your name into the trees may not be wise. They point out that we do not know what kind of mind could be behind the Saturn anomaly. It might be peaceful and curious. It might also think in a way we cannot. Imagine, shaped by a different sky and a different history of survival. To them, silence is not cowardice. It is a careful pause. The Saturn signal becomes a mirror. In its unexplained pattern, people see their own beliefs about humanity stretched out against a nebula-filled sky. Some feel destiny, others risk, and the same data carries both hope and unease, like a soft glow hiding a drifting shadow dot in quiet rooms. They talk about strategies. Maybe, they say, we do not send a message back yet. Maybe we listen longer. We refine our telescopes and spectrographs, trace the signal's trajectory more precisely, search for any hidden variations that might reveal more about its source. We treat it as scientists first, storytellers second. There is time. Space moves slowly, and an orbit around Saturn is not rushed. A few suggest a middle path. Instead of shouting into the dark, we could whisper. If we answer at all, the reply could be soft, simple, and cautious. A gentle beam, not a blazing flare. Perhaps it carries nothing more than a pattern that says, "We hear you." No map, no details, just a small acknowledgement. A nod across the endless night. Others say, even that may be too much. They argue that our first duty is to our own fragile world, before we risk becoming a clear target in an unknown universe. We should work on our own small sphere under its thin veil of air. We should steady our climate, reduce our conflicts, and make sure that if we are ever truly seen by a distant intelligence, we are more ready than we are now. As these views move back and forth, the tone remains gentle. There is no shouting here, no angry debates. Only people awake at strange hours, tracing possibilities on screens while most of the world dreams. Outside their windows, the sky looks the same as it always has. The same constellations, the same soft glow of distant stars. Yet, in their minds, the universe feels slightly different now. Slightly less empty. You, listening in the dark, are part of this question too. Imagine you stand on a hill at night, watching Saturn rise low on the horizon, its faint rings barely visible, a ghostly halo in the cradle of silence. If you knew that somewhere near that distant world, a hidden messenger might be waiting, would you call out? Or would you sit quietly, hands in your pockets, letting the night remain untouched? For now, the choice leans toward patience. The signal is logged, studied, compared, and checked again. Letters and reports are written in calm, careful language. No great beacon is switched on. No giant radio dish sends a bold new code into the sky. Instead, we do the thing we already know how to do best. We keep listening. The universe goes on. Comets trace their long, cold paths. Exoplanets circle their distant suns. Starlight passes through clouds of dust and gas. Somewhere beyond, perhaps, there are other minds making their own choices about when to speak and when to remain silent. For us, the Saturn anomaly stays like a quiet note held at the edge of hearing. It does not demand an answer, but it refuses to be forgotten. It lingers in data archives, in late-night conversations, in the dreams of those who stare at the sky and feel something looking back, between the urge to reply and the instinct to hide. Humanity rests in a delicate balance, like a small world poised on its orbit, neither too close nor too far from its star. And as the night deepens and the questions grow softer, the signal seems to drift farther into memory. Yet in that drifting shadow, the thought remains that somewhere in the endless dark, a listening ear may still be waiting. In the dark above Earth, the James Webb Space Telescope is not alone. It is the elder sibling in a growing family of watchers, each new telescope and instrument preparing to open its eyes to the endless night. You can imagine them as children of Webb, still on the ground for now, resting in clean rooms and labs, waiting for the day they will rise into orbit and join the cosmic dance. In a quiet lab, far from the noise of cities, engineers stand over a mirror segment the size of a small room. They wear white suits and soft boots that leave no dust. Every movement is slow, careful, almost like a ritual. A gloved hand makes a tiny adjustment to a screw. A laser line sweeps across the polished surface. On a nearby screen, a curve shifts by a fraction of a hair's width. This is how sharper eyes are born, not in sudden leaps, but in patient, precise touches. Future telescopes will see more than Webb, not because Webb is weak, but because it has shown us where to look. Its view of nebulae, exoplanets, and distant galaxy clusters becomes a kind of map. Designers use those images to decide where more resolution is needed, where wider frequency coverage will reveal hidden detail, where new spectrographs can tease out faint colors buried in the glow of starlight. In meetings that run late into the evening, They spread these images across digital tables and ask simple questions. How can we listen better? What did we almost miss? On another floor, programmers sit in front of softly glowing monitors. There, screens are full of lines of code, graphs, and simulated orbits. Outside, the sky is black, but inside, the only night is the dark theme of their software. They are building the new algorithms that will sift through oceans of data and search for the rarest patterns. To them, every anomaly is a training story. The Saturn signal, with its strange rhythm near the rings, is one such story. They feed its shape into their models and say, find more things like this, and also find things that are almost like this, but not quite. These smarter algorithms are like patient listeners in a crowded room. Before, we could hear only the loudest voices: exploding stars, roaring black holes, blazing comets at perihelion. Now, with better tools, we are learning to notice the softest sounds, the gentle whispers that hide behind the noise. A faint change in a pulsar's timing, a hidden kink in an asteroid's trajectory, a subtle variation in a nebula's glow. Each could be a clue, an unexplained detail waiting to be understood. Some of the new instruments will not fly into space at all. They will stand on mountaintops, high above the clouds, their mirrors catching cold starlight through thin air. Others will spread across deserts and plains, fields of radio dishes turning together like a slow, careful ballet. From the ground, they will listen for cosmic whispers that Webb cannot hear, tuning into frequencies where silent messengers might be hiding. Data from ground and space will flow into the same servers, mixing like streams into a single wide river dot in these rooms. The hum of cooling fans, the soft click of keys, and the low murmur of voices replace the roar of rockets. Coffee cups grow, cold beside notebooks filled with sketches of telescope designs and spectrograph layouts. Someone tests a simulation of a probe slipping into orbit near Saturn, tracing how its signal would bend and fade as it passes behind the planet's rings. On the screen, a simple line wiggles and then disappears, like a drifting shadow slipping. Under a gentle veil, the Saturn anomaly has already left its mark here. It is printed on slides, pinned in reports, and replayed in simulations. Not as proof of extraterrestrial life, but as a reminder of how fragile a signal can be, and how easily it could have been missed. It nudges people to widen their search, windows by a little, to let algorithms flag stranger patterns, to leave room in their models for the unexplained. In this way, a single anomaly becomes a quiet teacher, guiding the design of tools that will outlive everyone who first noticed it. Improved resolution means we will be able to see finer structure in the dusty arms of nebulae and the thin rings of debris around distant stars. Wider frequency coverage means hearing more of the universe's conversation, from low, slow radio waves to bright, sharp bursts of higher energy. More sensitive detectors mean that even weak signals, like a soft glow from a tiny exoplanet or a brief, unexplained flicker of starlight, will stand out against the cradle of silence. For you, lying in the dark and listening, it might feel abstract. A mirror being polished somewhere, a chip being cooled to a fraction of a degree above absolute zero, a spectrograph design shifting by a small angle. But each step adds up. Each change increases the chance that, when another strange signal passes by, it will not slip through unnoticed. The next messenger, whether natural or not, will find a world slightly more prepared to hear it. The people who build these machines are not always thinking about extraterrestrial civilizations. Often they are simply trying to measure a star's temperature more accurately, or map the orbit of a comet with better precision. Yet in the background, there is always that quiet possibility that somewhere in the data, hidden among patterns we do not yet understand, lies a sign that we are not alone. It is not a loud hope, It is more like a steady, patient expectation, like waiting for a distant echo to return across a still lake dot as night deepens outside. The labs become islands of soft glow. The code running on their screens tests new ways to separate true signals from noise, to tell the difference between a harmless glitch and a genuine anomaly. The Saturn story is one of their test cases, a memory they return to when they ask, would we catch it again if it happened tonight? In time, these next generation ears will open fully. Telescopes will launch, mirrors will unfold in the cold. Spectrographs will hum to life as they swallow starlight from galaxies farther away than any we see now. On the ground, arrays of dishes will turn together, tracking invisible waves that wash over Earth like a gentle, endless tide. Data will pour in faster than any person could ever read, and so the algorithms will take the first pass, flagging the strange, the unexplained, the almost familiar. And somewhere in that rising river of information, there may be another pattern like the one near Saturn, steady, structured, and out of place. Or perhaps something entirely new, a kind of signal we have not yet learned to imagine. As these new eyes and ears open, the universe will not become louder. It will become clearer. The cradle of silence will remain, vast and deep, but within it, more and more tiny details will come into focus. Each one a small light against the dark dot. In that clarity lies both comfort and mystery. Comfort, because with every upgrade, the cosmos feels a little less like an unknowable wall and more like a patient book we are slowly learning to read. Mystery, because the more pages we turn, the more questions appear in the margins. As you drift towards sleep, you can picture those quiet labs, those waiting telescopes, those unfinished lines of code, all preparing for the next whisper in the data. And somewhere far beyond the glow of cities, past the orbit of Saturn and the drifting paths of comets and asteroids, the universe continues to speak in its own slow language. One day, when these new instruments are fully awake, they may catch a word, a phrase, or a single clear note in that vast conversation, something small, but enough to change how we see the night forever. On any clear night, the same sky that James Webb studies in silence stretches over crowded cities, empty highways, farm fields, and sleeping neighborhoods. Far above the haze and streetlights, Saturn moves along its quiet orbit, an ancient traveler gliding on a path set long before human memory. The rings are invisible to the naked eye, yet they are there, wrapped in a gentle veil of starlight. Somewhere in that great cradle of silence, an unexplained anomaly once flickered in Webb's data, a possible signal, a cosmic whisper near the planet's shadow. Down here, under that same soft glow, people live, work, and wonder, often without realizing they are part of this story. In one apartment, a parent stands at a window after a long day, the city humming below. The sky looks faint, washed by neon and traffic, but a few stars still push through like tiny pinpricks of hope. The news about the Saturn signal scrolls silently across a phone screen on the table. The parent glances at it, then back at the sky, feeling that fragile mix of smallness and awe. Above the glowing skyline, telescopes orbit and listen. Their sensors and spectrographs aim toward that distant ringed world, while down here, someone simply whispers, "What if it's real?" On a quiet highway, a truck driver pulls into a rest stop, kills the engine, and steps out into the cool air. Out here, far from the city, the night is darker, deeper. The Milky Way hangs overhead like a faint nebula painted across the sky. The driver leans against the hood, neck tilted back, tracing slow arcs where planets move along their trajectories. Somewhere beyond that thin dome of stars, a hidden messenger may be passing by Saturn, repeating a pattern our machines have barely learned to hear. In the driver's chest, tired from miles of road, there is a simple feeling. He's small, yes, but not alone. Inside an airport terminal, a traveler waits for a red-eye flight. Planes glide in and out like slow comets with blinking wings. Through tall glass windows, the traveler sees only a handful of stars scattered above the runway lights. A headline on a nearby screen mentions mysterious signal near Saturn. But the sound is off, leaving the story floating in silence. The traveler watches their own reflection fade into the darkness outside. And for a moment, the glass becomes a kind of telescope, a thin barrier between a fragile human life and a timeless, endless night. The signal becomes less a piece of data and more a feeling that someone, somewhere, might be looking back. For many, the Saturn anomaly is never more than a story they catch in passing, a short video before sleep, a shared article, a sentence, overheard on the radio. Yet even in that brief moment, it plants a small seed of wonder. Humanity has always done this. Long before James Webb, people saw omens in comets and eclipses, read prophecies into the color of the moon, and feared that strange lights were harbingers of war or change. The sky was a book they could not fully read, so they filled the gaps with myth, hope, and warning. Those old stories still echo whenever we hear the word signal tied to the stars. Imagine a camp thousands of years ago, the fire's soft glow painting faces in orange light. Above them, without city haze, the sky is a river of starlight. A bright comet appears, its tail a drifting shadow across the heavens. Some call it a warning. Others think it is a messenger from their gods. They could not know about galaxies, exoplanets, or spectrographs, but the feeling in their chests is the same one people feel today when they hear about Saturn's mysterious whisper, a mix of fear, awe, and an almost painful hope that the universe is speaking to them. Now, the myths have changed shape. Instead of gods and chariots, we talk about civilizations around distant suns, worlds circling other stars on quiet orbits. Science fiction stories, streaming shows, and late-night radio all fold the unknown into new kinds of prophecy. The word alien carries less terror and more curiosity. A possible signal near Saturn becomes not a doom-filled omen, but a question mark written in the sky. Are we the only ones who dream? In bedrooms around the world, people lie in the dark, screens dimming beside them, and drift towards sleep with these thoughts settling slowly in their minds. Some picture a small craft, hidden among Saturn's moons, gliding through the luminous haze of the rings. Others imagine a far-off civilization sending out probes like bottles in a cosmic ocean, each one carrying a message in patterns of light. The truth may be simpler, a natural process we do not yet understand, a purely physical anomaly in the data, but even that is powerful. It reminds us that there are still corners of the solar system and the wider galaxy whose rules we have not fully written down. It reminds us that our knowledge, though growing, is still fragile. For scientists, the Saturn signal stands as a puzzle to be solved. For everyone else, it becomes a mirror. Under the silent sky, the story means something different to each listener. Comfort for the lonely, fuel for the imaginative, a soft nudge for those who have not looked up in a long time. The idea that the universe might hold other minds, other listeners, touches something deep and timeless. It makes our daily worries feel smaller and our shared existence feel larger, like we are all sitting together on a tiny balcony at the edge of a vast, starlit sea. Whether the signal is ever confirmed as extraterrestrial or explained as a rare natural phenomenon, its effect on human dreams is already real. It has gently shifted the way some people think when they see a planet's name in the news or notice a bright point of light above the horizon. Now, when a child hears the word Saturn, they might not only picture rings, but also a hidden whisper waiting in the dark nearby. As the night deepens and the world grows quiet, that thought lingers, a faint, persistent glow at the edge of our understanding, suggesting that even in our most ordinary evenings, the universe is a little larger and a little more mysterious than we knew. Far beyond the blue sky of Earth, Saturn moves along its slow orbit, wrapped in a soft glow of reflected starlight. Its rings stretch out like a gentle veil, each piece of rock and ice following a patient trajectory written long before humans learned to raise a telescope to the sky. Around it, comets fall inward and fade. Asteroids drift in the dark and distant. Exoplanets circle unseen suns. Nebulae bloom like silent brush strokes across the black. In all this motion, one small moment remains fixed in human memory. The night a silent signal was heard near the rings of this ancient traveler. James Webb was never built as a classic alien hunter. Its mirrors and spectrographs were designed to study the first galaxies, the glow of young stars, and the thin atmospheres of worlds far from our own. Yet, in one stream of data, buried inside the usual hiss of solar wind and background noise, an anomaly appeared. It did not flare like a supernova or roar like a pulsar. It arrived as a quiet, repeating pattern, a cosmic whisper that refused to match anything on the usual lists. For a brief time, that pattern stood like a small fire in a vast, dark room. Years pass. New mysteries arrive to claim center stage. A black hole brightens at the edge of a galaxy cluster. A meteor burns across our own sky. A comet brushes close to the sun at perihelion, its tail stretching like a pale omen against the dawn. Astronomers shift focus, adjusting instruments and models to follow the next question. The files from the Saturn signals slide into deeper folders, then into archives, but they do not vanish. They wait, quiet as a drifting shadow. One evening, much later, someone opens the data again. The room is dim. A monitor glows. The old graphs appear lines and spikes against a dark background. At first glance, they look simple, almost ordinary. Yet behind them lives the same unanswered question that once kept whole teams awake at night. Was this just our own machinery echoing back at us? A hidden natural messenger shaped by charged particles, by the ring plane, by a moon's passage? Or was it something else, an unknown traveler, tracing a forbidden pattern through the noise? Improved tools are brought to bear. Filters are rebuilt. Models of Saturn's magnetic field, its ring structure, and the flow of solar wind are more detailed now. Simulations track every possible trajectory. Dust grains, tiny ice fragments, charged streams sweeping past like invisible rivers. Each pass with new software turns the signal in a different light, like a small stone held up to the sun. Sometimes it leans toward a natural cause. Sometimes it slips free, remaining unexplained, a quiet secret that refuses to settle. Outside that room, life on Earth continues largely unaware. Children learn that Saturn is the ringed planet, that its moons glide around it like a small fortress. In space, they see it in textbooks and animations, glowing above the horizon in digital night skies. They might never hear about the silent pulse once logged near its rings. Yet, in soft-spoken documentaries and late-night stories played as people drift toward sleep, the tale circulates. A telescope, a planet, a signal that arrived without a clear reply. In those tellings, the signal becomes more than numbers. For some, it is a story of caution, a reminder that random noise can trick even the most careful mind. For others, it is a story of wonder and hope, proof that the cosmos still holds places where our understanding feels fragile. A few treat it like a quiet prophecy, a harbinger that we are not alone, even if proof remains out of reach. Each listener adds a layer of meaning, turning a short event into a long memory. On a clear night, someone might step outside, feeling the cool air on their skin. They may know nothing about spectrographs or data archives. Yet, they tilt there, head back and stare into the cradle of silence above. And the same feeling rises. the sense that the sky is both endless and close. Stars shimmer with a faint luminous haze. Somewhere beyond their sight, Saturn continues its steady path, rings casting drifting shadows over cloud tops, moons moving like pale lanterns in the dark. There is comfort in knowing that while they stand there, instruments are still awake in the night. Webb and other telescopes watch exoplanets for tiny dips in light, trace the shapes of nebulae, and follow the slow turning of galaxy clusters. Radio dishes listen for bursts and murmurs, small anomalies that might hint at new physics or at some distant messenger. One day, the Saturn signal may receive a neat label. Perhaps it will be tied to a subtle interaction in the ring system, to a moon's hidden ocean, or to the path of fine dust responding to magnetic fields. It may appear in a short paper, summarized in a few careful lines. Mystery narrowed, puzzle explained. Students will skim past it, their eyes caught by brighter pictures on the next page. Or perhaps it will remain unresolved, an entry in an old catalog with a note, source uncertain. Even that outcome has value. An unsolved anomaly teaches patience. It invites a gentle kind of imagination. It allows us to hold on to the idea that the universe is lawful and understandable, and at the same time, that it is bigger than our current tools and theories. It lets you fall asleep wondering if, somewhere beyond Saturn's orbit, beyond the drifting shadows of its moons, something once passed through, sent out a brief signal, and sailed on. Time, meanwhile, does what it always does. Saturn completes another circle around the sun. The rings slowly evolve as collisions grind ice and rock into finer grains. The sun flares and quiets, sending out waves of particles that brush every world in the system. Our own planet turns through storms and calm, through fear and hope, through years where we look up often and years where we forget to look at all. Yet the sky remains. People will keep listening to stories of black holes and supernova, of meteors, comets, and wandering exoplanets. They will hear about new signals and unexplained patterns that stir both excitement and care. Each mystery will join the chain that stretches back to early astronomers who charted stars by hand and forward to observers who have not yet been born. In the end, the signal near Saturn is remembered less for what it proved and more for what it revealed about us. It showed that a faint pattern, barely lifting above noise, could stir awe across a planet. It reminded us that our instruments, as powerful as they are, still catch only a fraction of the cosmic dance. It reminded us that we, too, are travelers, small beings on a moving world. Listening into the dark. As you picture Saturn now, try to see it as more than a picture, a living scene. In motion, the rings curve like bright brushstrokes, casting bands of light and shadow. The planet turns slowly, clouds swirling far below. Somewhere in that vast arena, a signal once flickered, a cosmic whisper that passed through our instruments and into our shared dream before fading back into the quiet. The universe does not stop when a mystery goes cold. It continues to move, steady and timeless, whether or not we have answers. But there is quiet power in choosing to keep listening, to turn our telescopes toward the dark, to wait without fear for whatever comes. And so the story rests, not with a sharp conclusion, but with a soft question that lingers in the silence. Beneath the endless night, beyond the rings and the drifting shadows of Saturn, somewhere between our world and the next, is someone else listening too? And have they already heard us?